Hi guys, Cheshire here. I hope you liked the first module about the compute or the computer. Now, in this module, we are going to talk about the network fundamentals. So, now that we understand what is a PC and how it is built, its components, and detail about its various components, in this module, I want to touch upon the fundamentals of network. What is it? How does it function? The building blocks and the terminology. Here is what we are going to cover. We are going to cover the need of the network. We are going to cover the address and the subnet mask and the default gateway and the DNS server. I'm going to show you how you define each one of these things on your own computer. We are going to talk about the hardware address or the MAC address of a network card. We're going to talk about the switches and the routers. We are going to talk about the routing tables. Wow. And we are going to talk about the DHCP and the DNS in the network. So, a lot of information. Get started to absorb everything. Okay, so the first topic, need of the network. Well, PCs alone by themselves were boring and useless, same as humans. Imagine we all own this world and we didn't used to speak to each other. Quite honestly, if we wouldn't have communicated to each other, then pretty sure there wouldn't have been so many of us, right? Same with PCs. Without the network, the PC wouldn't have evolved to the level that we have today. Ultimately, a PC or a personal computer symbolizes a human being communicating with another PC, which symbolizes another human being. Now, in this module, we want to learn how exactly the networks are created, the components of the network. IP address, that is the building block of the network. Imagine a big building with lots of rooms, like a hotel. Now, these rooms are connected to each other with hallways and elevators. But in order to identify them correctly, we need room numbers. And in order to identify the hotel also in this whole world, you need a proper address, which is again a number and a street name. Now, in this example, let's replace the hotel with a local office network and rooms with computers inside that office. So, in order to identify each computer correctly, like you need a room number for rooms, you need an IP address. And because these IP addresses are within a local network, we call them private IP address. And like the hotel need to have a unique address in this whole world with a street name and street number to be identified. Similarly, our office network need to have a public facing interface that needs to have an IP address which is unique in the whole wide world, and that IP is called as a public IP. So if you look at this diagram, these are the hotel rooms, the individual computers or the phone. This is your local network. These are the IP addresses of these machines. And now your router is talking to internet on an external interface, and this is your public IP address. So that's how this whole thing is made. Private IP addresses are local within a network, and usually following series are used. So there could be a class A network from in the series of 10, or they could be a class B network in the series of 172, or they could be a class C network in the series of 192.168. Once again, you can technically have IP addresses of whatever numbers you like them to be, but there are certain ranges which are reserved for private users, and there are certain ranges which are reserved for public users. So within your local network, you can start using public IPs to define your local network. Nobody is going to stop you, but that's not a correct thing to do because you can create a lot of confusion within your networks if you don't use the correct ranges. In most of the cases, in my life, I have seen that people use 192.168, 172.16, and 10.0 for the private ranges. So you can choose any one of them when you have to create a network. Public IP is unique in the whole world. Public IP addresses will be issued by an internet service provider and will have number ranges from 1 to 191 in the first octet, except for the private address ranges that starts from 10.00 in Class A, 176 to 16 in Class B private addresses. So public IP addresses are very funny. Like I'm not very used to look at them, but they can be anything in class A from 1001 to 126, or in class B from 128 to 191, or in class C to 192 to 293, and class D and class E you can see on the screen. The whole point of this exercise is for you to understand that there are classes of IP addresses in which it is segregated. Again, not something which you will be needing every day, but good to know that you have this information. Or at least when somebody says a class of an IP address, you don't start thinking what does he mean about it, or what does he mean by this. You need to have some kind of an understanding that the IP addresses have a class, and it's not a technical thing which you need to know in too much detail, but it's a fundamental fact that you have to know. And you should be, whenever you're defining a local network, you should remember that the IP addresses which you're going to use are either 10 range or 172 range or 192.168 range, and you don't start using any of the public IP ranges. Not that it is technically wrong and it will stop working, more than the reason is that you should not do it for sanity reasons. Loopback IP address. This address 127.0.0.1 is loopback internet protocol address or IP address, also referred to as the local host. The address is used to establish an IP connection to the same machine or the computer being used by end user. So in a lot of cases, when we are sitting on a machine and we want to refer to the same machine again in some kind of a code, or somewhere where we have to mention the IP of this machine while sitting on this machine, if we have to tell the machine to refer to itself, we used to write the loopback address. The only usage of this is I have seen when I define the DNS on a domain controller. Once again, these terms may sound a bit alien, so just take them as a statement for now. The domain controller is also the DNS server, and you want to point the domain controller to itself for DNS services. So in those cases, what we do is that instead of putting its own IP, which we can also do, we go ahead and put the loopback IP 127.0.0.1. Not something which you need a lot, but this is an interview question. Somebody can ask you what is the loopback address, and then you need to remember it is 127.0.0.1. Or if you see this IP address defined somewhere, you can at least know that this is referring to a loopback address. Next topic, after IP address, subnet mask. So what is a subnet mask? If we go back to the hotel example, you would have noticed on big buildings like hotels or apartments how the house numbers are assigned as a combination of floor number plus unit number. Like my house number is 404, which symbolizes that it is unit 4 on 4th floor. So in this example, floor number is the subnet mask. Let's look at the definition of subnet mask. A subnet mask is a number that defines a range of IP addresses that can be used within a network. A subnet mask are used to designate subnetworks or subnets, which are typically local network LANs that are connected to the internet. Systems with the same subnet can communicate directly to each other, while systems on different subnet must communicate through a router. Therefore, subnetworks can be used to partition multiple networks and limit the traffic between them. So the word subnet is actually subnetworks. If your building is divided into multiple floors, each floor has a floor number as the subnet mask, and the elevator which connects these floors is the router through which the traffic of the subnet talk to each other. I'll try to break it down once again. Subnet mask is the common part of the IP address. So if the IP address of your machine is 192.168 1.20, and if the subnet or if the IP address of the next machine next to you or the other machine in your network is 192.168.1.21, 1.22, then basically the first three octet are the same, and this is your subnet mask 192.168.1. Only the last octet of the IP address is changing. So the initial 3 units represent the floor number. Like I'm saying, my floor number is 4th and my unit number is 4. So my address is 404. It could very well have been 44. It's just the way my building apartment people decided to number the apartments. So it's 404. Now, similarly, in the subnetworks, the initial three octets remain the same and the fourth octet changes. So the initial three part will be called as subnet. The word subnet is subnetworks. So if your building is divided into multiple floors and each floor has a floor number as the subnet mask, the elevator which connects these floors is the router through which different subnets talk to each other. So every floor is a subnet and the router is the elevator. Because if you have to go from one subnet or one floor to another floor, you have to take the elevator. Let's look at the further definition. A subnet mask hides or masks the network part of the system's IP address and leaves only the host part of the machine identifier. A common subnet mask for a class C IP address is 255.255.255.0. So technically, what it's saying is that if my floor has 4 flags from 401 to 404, subnet mask hide the common part of the address, in this case 40, and just leave the host address 124 as the machine identifier. So subnet basically is the subnetwork to divide your big network. If it's a hotel, every floor is a subnetwork. If it's an apartment building, every floor is a subnetwork. And when you have to go from one floor to another, you have to take a router. So when you have to go from one subnet to another subnet, the communication will go via a router. So a common example of a subnet could be 255.255.255.0. That means that the first three octets are going to remain the same and only the last host part, which is represented by 0, is going to change. So 192.168.1.21, 192.168.1.22, 192.168.1.23 belongs to the same subnet. And 192.168.2.21, 192.168.2.22, 192.168.2.23 belongs to another subnet. So these are different sub-networks. Once again, good to understand information in general troubleshooting. Unless you are a network specialist, you don't have to go into much details of subnet and subnet mask, but it's important that you understand the importance of the subnet mask. It is what divides the subnetworks, or it is what defines the common part of the network. Next topic is default gateway. Now imagine that you're on my floor and you must go out of the building. What would you do? Take the elevator, correct? What if the elevator is not as obvious as it is on our floors? And in fact, it is behind a door, which looks exactly like 20 other doors on that floor. So just imagine a lobby where there are 20 doors. All of them could be a room or a flat behind them, or they could be an elevator behind one of them. And you have to go down that floor. You can't find which one is the elevator unless you knock on every door and try to find out what's behind it. Or the other correct way is that you know the room number, door number, or in our case, the IP address of the door behind which you have the elevator. And in that case, you can just straight away go to the elevator and get out of the building. And also remember how I explained that our floor is a subnetwork of the whole building. And to communicate with other floor or to go out of the building to the public network, you need the elevator. The elevator is the router. Now, like this example, we have a lot of PCs on various subnets in our office. Now, in order for those PCs to communicate to other subnet PCs, they need to go through elevator or the router. And hence, they need to know the address of the router or the exit point from the floor or their network. This exit point is called as the default gateway. The next hop after your machine where it can go to get out of the floor or to get out of its local subnetwork is called as the default gateway. Usually the first IP of the subnet is assigned to the default gateway router, like 172.16.0.1, 192.168.0.1. Usually the first IP of the local subnetwork is assigned as the default gateway, or is your router IP, or is your left address on your floor. Only after this, the rest of the IPs are distributed to the machines or the other nodes. Again, this is not a set in stone technical requirement, but this is more of a sanity requirement which everybody do it, or which everybody does, and you should also do, because if you don't do it, you can create some confusion in the network. Technically, you can give the default gateway any IP address and it will still work. Now let's check out the Google definition of default gateway. A default gateway is the node in a computer network using the Internet Protocol or the IP suite that serves as the forwarding host to the other network. Forwarding host to the other network, other subnetwork, when no other route specification matches the destination IP address of the packet. So, it is the node which forwards the data to the next destination when there is no other specification which matches the destination. Domain naming system, or the DNS. So far we have learned how IP addresses, subnetworks or default gateway function, and how each apartment in the building has an IP address or a flat number. Each floor is identified as a subnetwork, and how the elevator is the default gateway or the router. It all sounds excellent and perfect, except one thing: humans are lazy and we cannot remember a bunch of random numbers. What we can remember is names. So what we will know is that I want to go to Shishir's house or Shishir's room. But to go to Shishir's room, you need his room number. And you don't remember his room number. Hence, we need a system to which we can give a name, Shishir, and it can provide us, or it can resolve, or it can do a name resolution to its room number or its IP address. Once again, you arrive at a building and you have to go to somebody's house, let's say my house, Shishir. You don't know my room number. Are you not looking for somebody where you can go, like a reception or somebody, and you can say, hey, I want to go to Shishir's house, and they can tell you, yeah, that's 404. And then, yeah, boom, you take the elevator and you reach to 404. So this person who resolved my name into an IP address is the DNS, or the domain naming system. Let's check out its Google definition. DNS, the Internet System for Converting Alphabetic Names into Numeric IP Addresses, is DNS. For example, when a web server URL is typed into a browser, DNS server returns the IP address of the web server associated with that name. Okay, I will get into web servers and the resolution and these things furthermore. But what you need to understand from this definition is that it converts the alphabetic names into the numeric IP addresses. DNS contains various ways, should be read as records, in which the information is stored. So in a DNS server, it's just not like somebody is sitting with a book with the names and IP addresses. There is different ways and different kind of records which are possible. We will discuss all the records in a later part. In fact, there is a whole module on DNS, on the training during the Active Directory, because it is a very integral part of Active Directory. But there are various records in DNS. In this next section, what we are going to do is that I'm going to physically show you how do you define these different IP addresses and default gateways and DNS servers on a computer. So let's begin with a Windows computer, and for that this is all the process which I have written here. But what I'll do is that I'll just quickly jump to a Windows PC and show you how do I do it. Okay, so we are back on my Windows server, And what I'm going to do is that I'm going to open the network connection. It says ncpa.cpl and click on OK. Let me just close this, Internet Explorer, close this. This is the network card, and I go to properties, and and remember, you can have multiple network cards on your network connections window. That's because even the Bluetooth connector shows up here, the Wi-Fi connector shows up here, the cabled network connection shows up here, and depending on which network interface you are trying to define, you need to open the properties of that. When I say which network interface, so your computer can be connected to multiple networks, and if it is connected to multiple networks, it will have multiple IP addresses. Now, you need to decide which IP address you are going to give to the machine, or to which network you are defining the IP address to, and you need to open the properties of that particular network card. You go to Internet Protocol IPv4 version here, and you go to its properties, and you see here it's set as obtain IP address automatically. So DHCP server, which we are going to study next in our networking knowledge information, that's going to provide it the IP addresses. But if you want to provide a manual or a static IP to this machine, you put it here, and you go ahead and type the IP address here. Whatever you should know what your network and your subnet is, and you put that information here, and you put that information here. You put the subnet here, and then you also provide the default gateway here on 192.168.1.1, and then you provide your DNS server. So once again, to remind you, DNS server is the person or the system which is resolving the name to IP addresses. So this is again a component which is installed on a Windows server. So you need to provide the IP address of that Windows server, which is acting as the DNS server in your environment. So 192.168.5 dot. It could be anything. I don't have a DNS server, but it could be anything. So you provide some IP address. Maybe this is our DNS server. You have an option to provide more than one DNS servers here. In fact, if you go to advanced, you can provide quite few DNS server, and depending on their priority, 1, 2, 3, 4, the first one will be used, and the second one will be used, the third one will be used. So that's how you provide the DNS information on a Windows machine. Having said that, let's have a look how do we provide it on a Mac. So on your Mac, you go to Network Preferences, and you go to Advanced, you go to TCP/IP. Once again, you can see it's either picking up automatically using DHCP, and you can see these are the IP addresses which it has given to me, or I can say manually, and in that case it gives me the option to provide the IP addresses here and DNS here or whatever, and I can just provide all this information, click on OK and apply, and then I'll be done. Okay, so that's how you define the IP addresses on a machine. I'll go back to the training. So like I mentioned, you can open the network preferences and you can define it here. You can go to advanced settings and you can define this IP addresses. How to validate the IP addresses? Once again, if you want to just look at your IP addresses, you can go to the same panel where I went, but as you saw there, it wasn't giving me a lot of information. So let me go back to my server. Okay, yeah. So if it is a manual IP address, you can go to ncpa.cpl, you can go to the properties of this box, and you can look at the IP address if you have defined it here. But if it is obtain IP address automatically, you might not be able to see it like this. In that case, what you can do is you can right click and say status, and yep, so here it's showing you the IP addresses and the DHCP server and the DNS server. All this information is picked up by it automatically. Or the best way to do it is just open the command prompt and type the command ipconfig, and the ipconfig command is IP configuration short form, and it shows you your IPv4 address, it shows you your default gateway. Once again, it could be an interview question where they ask you how do you check the IP address of a machine. You can say that you can even go here, right click. There used to be a status button here. I reckon it's not there anymore. Let me see. Yeah, but anyways, all these options are correct options, but all smart people like to listen to ipconfig. So when somebody asks you, how do you find the IP address of your machine? You say, I open the command prompt, start run cmd. Once again, start run. And just to tell you, the run used to be here before in the earlier operating systems. It's missing. So what you can do is you can right click on the start button and the run will show up, and you click on CMD and the CMD will open up, and in the CMD window, ipconfig, and it gives you the IP addresses. If there are more than one IP addresses or more than one network card, all those network card and their IP address will show up here. And if you notice, it's not telling you the DNS server, and for that you have to do ipconfig/all, and it gives you a lot more information. So here's your IP address, here's your subnet mask, here's your default gateway, here's your DHCP server, here's your DNS server. So you get to see all the information here. And incidentally, the DHCP server and the DNS server have the same IP address, but that means nothing. They can be on the same server, they can be on a different server, it doesn't matter. So anyways, well, that's how you check the IP address of your machine. Going back to the training. To validate the IP address on the Mac, you can do Open Terminal. Terminal is the equivalent of command prompt from Windows. So what you do is you press the command and space bar, and you will see the spotlight window opens up on a Mac, and here you can type terminal, and terminal, you can double click on it and the terminal will open for you, and then you can run the command ifconfig, if instead of ipconfig. It's a Linux based shell. The command is different. You write ifconfig, and this gives you the IP address somewhere here. But if you need a cleaner way to provide the IP addresses, then you can go to this command ifconfig and get if address, this whole command. Yeah, just after the $sign ipconfig get if address in 0, and that gives you the IP address in a very clean way. All right. Now we move to the next topic which we have, and that's the network equipment. Switches and the router. Let's talk about the heroes of our network, the switches and the routers, and the difference between them. Switches. A network switch is a networking hardware that connects devices on a computer network by using packet switching to receive and forward the data to destination devices. A network switch is a multi-port network bridge that uses MAC address to forward data at the data link layer of the OSI model. Okay, I hope in your college you would have done OSI models, the 7 layers of networking. If not, just to read about it. Again, not something which you use every day in your work, unless you are a network enthusiast and you specifically work on network. But even in those cases, this is all good to have knowledge, and this gives you a strong understanding of the situation. So, yep, if you don't know anything about the 7 layers of network or the OSI layer, then please read about it. Now, in my definition, in easiest terms, I see switch like a power strip, which we have at our home. So power strip, I don't know what you call it, extension board, power strip, where you don't have a lot of socket connections. So what you do is that you put a plug of the power strip or the extension board in the wall socket, and then suddenly you have got 5 or 6 sockets available to you to plug in your devices. It's just a way to increase the number of inlets available in a wall socket or a network in this case. A switch do not have support for multiple subnets. All the machines connect to a switch will have the same IP ranges or subnets. So switches are dumb. They will support a particular subnet. So like I said, they are just an extension board. And I know those of you who have knowledge of switches would know about layer 2 and layer 3 switches capable of routing as well. But then, guys, though they are called as switches, but as soon as they have a routing capability, they will also become a router. So, switching in the plain and simple term means a same subnet increase in the number of ports. If a switch is doing routing, then it's a router plus switch. So now what is a router or a routing? Routing is a process of selecting a path of the traffic in a network or between or across multiple networks. Broadly, routing is performed in many types of networks, including circuit switch networks such as the public switch network, telephone network, and computer networks such as internet. Okay, that's way too complicated. Um, Basically, router connects multiple subnetworks to each other, and if you have to go from one subnetwork to another subnetwork, you need to have a router. So as you can see in this diagram, so this is one network, then this could be a switch maybe, then this is going here, and this could be a router. Similarly, these could be routers. A router is a networking device that forwards data packets between computer networks. Okay, so routing was the definition of the process, and router is the actual router, the physical thing which we get. A router is a networking device that forwards data packets between computer networks, so between different subnets. Router perform the traffic directing functions on internet. Data sent through internet, such as web pages or email, is in form of data packets. So once again, what it's trying to say is that whatever data is sent on internet, whether you are trying to browse anything or whether you are trying to send an email, everything goes in form of data packets. And the job of the router is to route the data packets between different networks. So whenever the information is leaving from one subnetwork and it's going into another subnetwork, a router has to do that job, or it has to do the routing. Okay, I think we made routing clear before as well. Routing is a connection of two different subnets. Now, typically, the router we see in our market solves the purpose of a small switch as well, as they have 3-4 LAN ports behind them. If you don't have too many devices, especially now that devices are more Wi-Fi, then this pretty much is good for you. So this is a photograph of a standard home-based router which is available. As you can see, these here black ones are all the LAN ports which are available. The yellow one is the WAN port, which is again, like I said, two networks are merging up. So this is an external network which is coming from your ISP, and these are the internal network. And this router job is to merge these two network or route the traffic between them. And you can have all these sorry these antennas. They serve as the Wi-Fi antenna, and then a lot many more devices than a standard 5 or 8 ports which are available on it can connect to it. So this is the Wi-Fi router which is acting as a switch as well. A good way to identify a router would be that it will have ports for two separate subnet. Like the most common routers we have at home have a port for WAN and 3-4 ports for LAN. So, like I said, once again, these are the LAN ports and this is a WAN port. And because this is a router, it is transmitting the data between two different subnets. The public subnet, the WAN, or the local subnet, which is the LAN. Hardware addresses or MAC addresses. MAC addresses, also known as physical or hardware addresses of a network card, are burned into a NIC card by the manufacturer. So apart from IP addresses, every physical NIC card, whether it's there in your phone or it's there in your computer, whether it's Wi-Fi or whether it is a wired NIC card, they have something which is called as a physical address. And this is not like an IP address which you can define on it. They are a 12-digit hexadecimal number, 48-bit in length, and by convention, MAC addresses are usually written in one of the following formats, and they are written by the manufacturer when the device was manufactured. So the format of the network hardware MAC address is this MM:/MM:/MM:/. SSSSSS. So basically, this M or S could be any alphabets, but that's how long it is. MAC addresses are used for communication at switch level. Remember, at switch there is only one network. A switch doesn't talk to two networks, it talks within a subnet. And it identifies all its clients using their MAC address. And it keeps learning their MAC address as they are joined to the network. And while learning the new MAC addresses and IP addresses associated with them, Switch creates something which is called as the ARP table. So remember, there used to be a DNS. The DNS was where you identify the name, basically resolve a name into an IP address. Similarly, when the data packet reaches a switch has two options. Either it can broadcast the data to all of its hosts. So basically, just when somebody, a delivery man, reaches your floor, that is your switch level network, which is the same subnet. What he can do is that he can go ahead and knock the 20 doors of the network and try to find out where the guy is. Or what they can do is that the switch maintains something which is called as the ARP table, which identifies the hardware address of a NIC card to the IP address which is on them. So a switch clearly knows which hardware address is which machine, but it doesn't know which IP address is with that machine, because in the OSI layer, the switch is not that smart to understand the IP addresses. It can only understand the hardware addresses. So a routing table between the hardware address and the IP address is called as a ARP table. ARP stands for Address Resolution Protocol. System keeps an ARP lookup table when they store information about what IP addresses are associated with what MAC addresses. When trying to send a packet to an IP address, the system will first consult this table to see if it already knows the MAC address. In fact, if there is a communication sent for an IP address for which the switch do not have an entry in its ARP table, then switch is going to broadcast the information to all the nodes, and the correct node will accept the information, and the switch is going to make an entry for future in its ARP table so that it doesn't have to go through that process again, and the next time the communication can be faster. So an ARP table is kind of equivalent to a DNS resolution, but this time the resolution is between, in DNS it is between name and IP, and here it is between hardware address or the MAC address and the ARP. So I quickly want to show you the hardware addresses as well on my Windows machine. So what I'll do is I will go here and I will go here, and I did ipconfig all. Okay, see, this is a virtual adapter and this is the physical address of it. And this is the real adapter and this is the physical address. So once again, if you want to know the physical address or the MAC address of any network card, you have to run the command ipconfig all, and this will tell you the hardware address of the network card. I might be able to show it to you here as well. Not sure if it shows up in this window or I might have to go somewhere else, but I'll try to look. Yep. So this is the MAC address or the physical address of this Wi-Fi network adapter. If I go to, if there is a physical network card, no, physical network card is not showing here. So I can't tell you that, but every device will have a MAC address. So this Targus 3, this is an external virtual device and it is not connected to the machine, so the MAC address is not showing here. This is a VPN, and the VPN also will show the hardware address once it is connected. Right now it is not connected. So, alright, so that's the hardware addresses and the MAC addresses of the machine. Let's go back to the training. Okay. I hope you understand the ARP table now. Okay, so the next topic is DHCP server. I know we have enjoyed the analogy of building and rooms within it to represent the IP addresses and network, but I for now will have to move away from that, considering that everyone now understands the IP addresses and the network concept. DHCP servers are simple. Let's say you are asked to set up a network of 10 computers in an office, which gets internet from an internet service provider. ISP has connected the WAN cable on this yellow port to the provided router. And there are 4 ports available for the LAN connections, like these black ports which you have there. Now, because you have 10 local PCs, we are talking about wired network connections and not Wi-Fi. You need to increase the number of LAN ports. So you brought a switch. Like I told you, that switch is a dumb device. It basically works as an extension point to create more number of ports. You connected the switch with the router and then connected 10 PCs to the switch. So this is what has happened. Your router is here, ignore this PC in between. The switch is directly connected to the router and then all the PCs are connected to the switch. Now the whole network is complete, except none of the devices have any IP address. You didn't provide any IP address. Who is giving all these IP addresses? I told you that you can define the IP address, go to ncpa.cpl, go to the network card properties, TCP IPv4 properties, and define the IP addresses there. So we didn't do that. Other than that, the physical connectivity of the network is completed. Now, to give the IP addresses, what you can do is you can create a LAN IP range on the router, and I'll quickly show you my router as well after this page. So you can create a LAN IP range on the router, and by default the first IP will be assigned as the router LAN interface, and this is going to be your default gateway, and you can assign IPs manually to the switch and all the other machines. So you can give an IP to your switch and then you can give IP address to all your machines. This practice is acceptable maybe if you have 10 machines. But can you manually and without any human error assign manual IPs to 100 machines? Imagine a situation where your router is also a Wi-Fi and all user phones are also connected to it. Can you give them static IP too? Technically, maybe yes, you can, but realistically, it's not possible. Who all can you keep telling their IP addresses, and will they go ahead and put the IP addresses correctly on their computer or on their phone? It'll be too much of work. And you can create a human error. Maybe you will tell the same IP addresses to 2 people, and both of them will configure the same IP address on their computer or on their phone, and you create a network conflict. It's not possible. Hence, you need a DHCP server or a dynamic host configuration protocol server. Let's look at the Google definition. The DHCP, or the Dynamic Host Configuration Protocol, is a network management protocol used on Internet Protocol network whereby a DHCP server dynamically assigns an IP address and other network configuration parameter to each device on a network. Okay, so that's the only important part of the definition, where it says DHCP server dynamically assign IP address. So IP address is number one. And other network configuration. Other network configuration consists of the default gateway and the DNS server and the subnet mask to each device on a network so that they can communicate with the other network. The DHCP server role is to provide the IP address, the default gateway, and the subnet mask and the DNS to the machine. A DHCP server can be installed on a Windows machine, and it can also be installed on a Linux machine. But in most network, DHCP server is usually placed on a network router or a dedicated device. DHCP role is very simple. We just install the software which is part of the Windows server by default, or additional software in case of Linux or Unix, and define an IP range. Now, if the DHCP server is in the same network, it will start assigning IP addresses to the machine which will request IP from it. And the process of requesting IP is this, which is client send ahead a discovery request that where is the DHCP server. The DHCP server sends an offer that I am a DHCP server. The client requests an IP address from the DHCP server, and the server acknowledges the request of the IP address and it provides an IP address. This process is called as DORA. DORA. It is once again an interview question, that what is the DHCP process, or what is the DHCP process to assign IP addresses? And the answer is DORA, discover, offer, request, and acknowledge. Along with the IP addresses, like we read in the definition, it also sends the configuration like DNS and default gateway to the client. Another benefit of this approach is that if you change the IP address of your DNS server or the IP of the default gateway, you can simply update the information on your DHCP server scope and it will get updated on all the clients. Imagine you had 100 PCs and you were lame enough to go ahead and give IP addresses manually to each and every PC. And as soon as you got back to your seat and your boss asks, you know what, we have changed the IP address of the DNS server. Can you go back to the 100 machines and change the IP address of them? That's stupid. Whereas what you can do is that you can just go to the DHCP server and define the IP addresses there. I'll quickly show you my DHCP server somewhere. So this is my DHCP server 192.168.1.1 maybe. Yep. So I don't. This is my local network, and I'm not running a DHCP, Windows DHCP or a Linux DHCP server here. This is my local router, which is acting as my DHCP server. So what we are going to do is we are going to go to advanced and just don't worry about the network configurations here. This is not something which you really need to think about. What you need to think about is the network, and then you LAN settings, and then you see here that we have the DHCP server here, and I have defined the IP addresses. Then I have defined the IP address range. So DHCP server is working from the IP address 1.100 to 1.199. That means it can distribute 99 IP addresses to the clients, and they are going to be between this range. I've also defined the default gateway. So to whoever machine it devs the IP address, it will also tell it the default gateway, which is going to be there, and it will also give them the DNS server IP address. So this way, every machine gets the configuration from the DHCP server. Now, a similar software can be installed on a Windows server. Let me show you real quick. So if this is your Windows server, we are going to talk about the Windows server later, but I'll just quickly show you how you install a DHCP server. So you go to next and you go to role-based feature and then you select server. Then you go here and you just put a check on DHCP server and you can say add feature, and then this is some error message which is going because this machine doesn't have a static IP address, and if you want to make it a DHCP server, it is recommended that you have a static IP address on this machine, but we are not going to worry about that for now, just because I'm canceling it. But you basically put a DHCP server check mark here, you click next, 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 and the DHCP server get installed. So that's how you install DHCP server on a Windows machine, or in most cases, like I said, that you will be doing it on a router like this, which already has everything, and you can just simply go ahead and configure the DHCP server. There could be only one DHCP server in your network. Otherwise, you can create some kind of a havoc. DHCP is a bit of a dumb process. Anybody who goes to a DHCP server, it will start assigning IP addresses to it. So if you have more than one IP addresses, you can create some kind of a network confusion. That's like, and if there is two DHCP servers and both are distributing this IP range, then maybe this machine will go ahead and give the IP address 111 to a particular computer, and then the other DHCP server will also go ahead and give the IP address of 111 to that machine, and it will become awfully difficult for you to figure out that why is this conflict happening until you discover that there are two DHCP servers which are running in the environment. All right, going back to the course. Okay, so DHCP terms, again, these are some of the terminologies which you need to understand. DHCP scope, this is the IP range which you define to be distributed by your DHCP server, like from between 0.1 to 0.20. The scope can only distribute 20 IP addresses. Just before I showed you my DHCP server, and it was configured from 100 to 199. That means it can distribute those 100 IP addresses. DHCP lease, this is the time duration for which an IP address is valid for a client. So when you assign an IP address to a machine, you basically tells it for how long this IP address is valid, and once this time duration is over, client need to renew the IP address. It can get the same or the different IP address at that time, but it generally remains the same unless the client was offline for a long time. So basically what I'm trying to say is that lease is the time for which the IP address is valid, and when the client usually renews it, it gets the same IP address again. But just in case you turn off the machine for a while and it IP address lease expires and its IP address is taken by another machine which requests the IP address during the time it was turned off, and when this machine boots back up, it can get a different IP address. That's very well possible. So that's what DHCP lease is. DHCP reservation. So sometimes we need certain clients to get the same IP address every time they request, like on your network printers or your televisions. So we create a reservation using the client MAC address in the DHCP table. This way, DHCP server do not issue the reserved IP address to anyone else, but only to the client which has reserved it. So this is a way where we set some kind of reservation so that the particular IP addresses are not issued to any other device, and you need this information to provide dedicated IP addresses to the devices. Like in my network, I think I would have given a dedicated IP address to my printer, and the reason for that is, yep, so these are the IP addresses for a couple of my devices, because I have to log into these devices. I don't want to always go and check what IP address they have got. So I have created reservation. So this is called as a DHCP reservation, which is there. And exclusion range, it ensures that an IP address listed in that range is not offered by DHCP server to any DHCP client. So let's say that you have created a range from 192.168.1.10 to 192.168.1.99 as your DHCP range or the scope, but you don't want to assign the IP address 51 and 52 to any machine for whatever reasons. So you can put 192.168.1.50 to 192.168.1.55 into exclusion range, and this way all the IP addresses between this range will not be offered to anyone. So that's what an exclusion range is. DHCP client is any computer that has DHCP settings enabled. It is a DHCP client. Remember when we were defining the IP addresses, I showed you how you can obtain the IP address automatically or how you can obtain the IP address manually. So when you set it to automatically, that means your client, you are becoming a DHCP client and you are looking for an automatic IP address configuration. And DHCP server is the server which is running a DHCP server. So in my case, my router is a DHCP server. If I go ahead and configure a Windows server in my network as a DHCP server, then that becomes a DHCP server. All right, that brings us to the end of DHCP. And next comes the DNS, the mighty DNS. We already discussed DNS server briefly in this module. We already know that its is used for name resolution. DNS server can be installed both on Windows and Unix and Linux server. We primarily focus on Microsoft DNS server in our training, but the fundamental for both DNS servers are same. So Microsoft DNS server is part of Windows Server. You can install it as a role on a Windows server. We will do it as practical for same after introduction of Windows Server. Let's start by defining some of the terms. Okay, I'll quickly show you how do you install once again the role which you can install to install DNS. So server manager, add roles. See, DNS server. The role for DNS server is available. You can put a check on this and you can follow the installation path and it will install DNS on the machine. All right. What are DNS zones? Now we are just defining some of the terms in DNS. A DNS zone refers to a certain portion or administrative space within the global name system, DNS. Each DNS zone represents a boundary of authority subject to management by certain entities. The total of all DNS zones, which are organized in a hierarchical tree-like order of cascading lower domain level, form DNS namespace. Okay, that's very complicated. I'll show it to you. So a DNS zone is basically divided into two kind of zones, forward lookup zones or reverse lookup zones. Forward lookup zones. These are the zones which resolve IP addresses of given names. You give them a name and they'll provide you the IP addresses. The primary purpose of the DNS. Reverse lookup zones. These, as the name suggests, does the reverse of forward lookup, which is to resolve the name of the host from the IP addresses. So you tell them the IP addresses and they tell you the name. Honestly, they are usually not of much use in whole Active Directory environment, but it is created as part of the default installation, the reverse lookup zones. And there are very specific reasons for them for you to have them in your Microsoft DNS server. But in most cases, even if you delete them, they're not going to cause a lot of issues. Now, under forward and reverse lookup zone, you can create various other zones like yahoo.com and mybusiness.com, etc. So this is a forward lookup zone. And under forward lookup zone, this is one zone which you have created. This is the other zone that you have created. This is the third zone which you have created. In AD environment, the default zone is created as per your Active Directory domain name. Below is how a Microsoft DNS console look like. You're going to learn more of these things when we install Active Directory and those things, so don't worry too much. Apart from default AD DNS zones that are created, you have ability to create various other zones as per your business and network requirement. DNS zones are just the outer wrapper of the whole story. The actual work is done by the various DNS records, which are present underneath the zones. Let's learn more about the DNS records available. Now, this is an interview question, and you need to understand what are the DNS records and what is the use of them. A record is the most commonly used record. It is also called as the DNS host record. It stores the host name and its corresponding IP address. So this is the mapping using which when you give an IP address, when you give a name, the DNS is able to provide you its IP address. That is the host record. IP version 6 AA record, again it stores the host name and the corresponding IPv6 addresses. IPv6 address is a new generation of IP addresses. They are not in much use as of now, but considering a situation where the IP addresses are getting vanished, new IPv6 ranges are coming in, they provide you more options to provide IP addresses, but they are still not full-blown as of now. Most of the devices are running on IPv4 addresses. CNAME record. So CNAME is the next record. It can be used to alias a host name to another host name. When a DNS client requests a record that contains a CNAME which points to another host name, the DNS resolution process is repeated with the new host name. Okay, so a CNAME is like referring one address to another address. So let's say you're looking for www.yahoo.com. And when you go into DNS, the entry for www.yahoo.com will point to www.amazon.com. This way, and then there is another DNS entry in the Amazon zone which points to www.amazon.com is equals to 192.168.2.3. So which means www.yahoo.com is equals to www.amazon.com. This is a CNAME, and then www.amazon.com is equal to 192.168.2.3, and that's an A record. So a CNAME record is a record which is an alias record, one record which refers to another record. When you will create it in DNS, it will make more sense. MX records specifies the SMTP server for the domain used to route the outgoing emails to the server. So MX record is basically to identify the mail server of your domain. The MX record for any domain identifies the IP address of the mail server which is running the emails for it. The name server record identifies the principal DNS server IP addresses for a particular zone. If you are hosting yahoo.com, this zone is going to be replicated in the DNS servers across the world. However, there is going to be a particular server which the yahoo.com owner is authoritative to edit it, and that's what is called as a name server record. Reverse lookup record or a PTR record, it allows DNS resolver to provide an IP addresses to receive a host name. This is the reverse lookup zone which I was talking about. It resolves from the IP addresses, it resolves a name. SRV records, these are the service location records. like MX record, but for other communication protocols. So there are SRV records which identifies some services. So if you are running, let's say, a communication server like a Link server or a Skype server in your environment, and somebody wants to find out what is the IP address for that server, you publish a SRV record for that. It is a service record. Text record. Once again, it is a type of a record which is used to identify something. It is basically a record which allows you to put a lot of text in it. Uh, you typically use it for SPF records or DKIM records or DMARC records. Once again, something which we will learn during our email configuration, SRV records and PTR and text records and MX records. Start of authority record. This record appears in the beginning of the DNS zone file and indicate the authoritative name server for the current DNS zone and the contact details of the domain administrator, domain serial number, and information on how frequently DNS information for this required. So start of authority is again just the record which identifies the beginning of a DNS. Once again, most of these records are not very important for you, but you should know what is a record, you should know what is a CNAME record, you should know what is a MX record, and you should know what is a TXT record, and maybe a PTR record. The rest of the record, usually people not ask you. But these are important information, and if you can learn about all the records and their understanding, that'll be amazing. But if you're not able to understand some of them, you can ask me more questions, and I'll be happy to answer. And moreover, some of these DNS text records will become very clear to you when we go into the further advanced concept, because those records are being used there. And it is highly important for you to understand these basics for now, that these records exist, because we are going to refer them in future, and at that time we will provide you more explanation of these records. Here's the action item for yourself. Check out the IP address of your machine and maybe try to set it to a static IP address if it is dynamic by going to ncpa.cpl and network card property. Try to figure out ipconfig and ipconfig all. Use what is my IP to identify your public IP. So like I told you that whatever internet you are using, there is definitely a public interface in your network which your router is talking with, and there is a public IP which is defined to your machine. So what you can do is you can go to any website like this, and these basically tell you what is your IP address. Apparently, it is showing that my IP address is in Brisbane, which is surprising. But anyways, this is the IP address which it is showing for me. So similarly, you can do what is my IP and figure out what is your public IP. You will need the public IP information a lot when you are configuring a network and when you are trying to host a server inside your network and you want to access with this network outside your network, then you need to have the public IP information. This is a handy tool which I use, so I would like you to have a look at this as well. And use NSLOOKUP to query various DNS records. Change the DNS server in NSLOOKUP to 4.2.2, and that's something which I would like to show you. So you can go, let me go to a Windows server, and let me go here, and let me open a command prompt. NSLOOKUP is a tool which you use to do DNS lookup. I will do CLS, I will do NSLOOKUP, and now this is showing the DNS server which is known to my machine. I can go ahead and ask it what is google.com IP address, and it tells me the google.com IP address. I can tell it yahoo.com IP address, and it will tell me there are multiple IP addresses for yahoo.com. These are the IPv6 addresses, by the way. I can say, tell me the text records of yahoo.com. So set type equals to txt. Sorry, set type equals to txt. And I can say yahoo.com. So these are the text record which Yahoo people have published. As you can see, the text records are basically textual record. They are used for verification purposes and for some reasons, so they are there. Then let's say that I want to look for SRV record, so I'd say set type equals to SRV. Okay, maybe the syntax for this is something else. I will have to look into it. So let's say I type set type equals to MX. Sorry about it. Let me just quit it and do NS lookup once again. Set type equals to MX. Okay, I think SRV should also work. I don't know why it was not working. And I say yahoo.com. Okay, these are the IP addresses. These are the various mail servers which Yahoo hosts, and these are the IP addresses behind them. I know it's a bit complicated to understand, but the only thing which you need to understand at this moment is I did set type equals to MX and I queried yahoo.com, and this told me that these are the names of the Yahoo mail servers, these three. And I can also do, say, google.com, and these are the mail servers for Google. You can query them. And these queries have to work perfectly because, you know, when you are delivering emails, in the background, some system is running this query. If Google stops providing this information, then the emails will not get delivered. A system has to find the Google Mail server, and that's what's happening here. So that's that. And yeah, so those are the DNS record. Let me try the SRV again. Set type equal to SRV. Yep. And I say google.com. Let's see. Okay, it didn't find any SRV record for that. Let me look for my company, pledgetechnologies.com. Okay, it didn't find a SRV record. SRV records are not very common, so there might not be a SRV record for my domain as of now. So yeah, this is what I wanted to show you. So get familiar with NS lookup, maybe read more about it, understand more about it, read more about the DNS record, learn more about it, and question yourself. Uh, Once again, log into your own router and look for various options in it. Look at the LAN IP, the WAN IP, and the DHCP. Remember, I showed you my router. So you can also log into your own router, and if it's default gateway, you can look at your machine, you can do an IP config, and you can have a look at your default gateway IP address, and that's what your router IP address is. Put that here. It will ask you for the credentials. If you know it already, then good. If you don't know it, then go ahead and look on the backside of your router. There will be a default username and password mentioned there. So log into that, and then yeah, you can go here and you can go into network. Okay, it's asking me to log in again. And basically go to advanced. Again, your router can have a different interface. This is the public IP which I have. This is the public IP default gateway. This is my DNS servers which are there. And then you need to look at the LAN settings. This is the DHCP server which I have defined. Is the range. These are the client list. This is the address reservation which is there. So all these kind of things, and there are various options which are available. Just have a look; it will give you a lot of information. So check out these things and learn more about these things. And with this, we can conclude our action items and this module about network. I know this was a lot of information, and I would like you to replay this module again and again. If you have some questions, then Google those things. You have to remember that this training The purpose is to point you to the right direction. There is no possible way in which I can give you all the information. I'm happy to answer all the questions for you. I'm happy to answer whatever you need from this training to make it more successful. But if I start going into the detail of each and everything, this training will become very, very, very long, and we don't want to do that. So you have to do a little bit of work. Google it, search it. If you come up with more questions, I'm always available to answer your questions. So take care, guys, and I'll see you in the next module now. Thank you. Bye bye.